Let's start with this one, then go to this one. So whenever we have fractions that are equal, that are added or subtracted, I must have denominators that are equal to each other. So I have here x over x plus y, and then plus y over x minus y. So when you think about the denominators, apparently I need to multiply this by the x minus y up and down.
Yes.
Because whatever I multiply up, I multiply down. Yes. Alim?
Yes.
What were you about to say, Habib?
No, I just said that.
Okay.
I did this.
So what happens next is we multiply and so on. Now I'll leave the multiplication for now. I'll just leave it as x. Oh, actually, okay, multiply. It becomes x squared minus xy plus xy plus y squared. This is the numerator. So I distributed and I distributed and I got this. For the denominator, I'll have x minus y and x plus y. Only once, not 2 times. So far, is there any problem?
No.
Awesome. Now let's add like terms. So negative xy and positive xy will cross each other. So then I'll have x squared plus the y squared. All of this is then over. Now this is what we call a difference of 2 squares. Whenever we have 2 brackets that are exactly the same with different middle signs, it's a difference of 2 squares. But if you forgot that, you still have to distribute. And once you do that, you'll get x squared minus y squared, which then gives me e. Does this make sense?
I thought we should simplify the 9b.
We can't actually simplify.
Yes.
We can't. We can't take the square root of things that are added to each other and then remove the power of 2. So the square root doesn't go this way. If that's the reason why, for example, you have the square root of a squared plus b squared, but not just a plus b, because this is different than that. Make sense?
Yes.
Okay. Okay, moving on. 49. It says point M will remain fixed and point Q will move to the right along the x-axis as Q continues to move to the right. Which of the following statements describes what will happen to the slope of MQ?
This one has a
graph.
Graph, yes.
How does it? Okay, what does the line right now MQ looks like? Like, is it a positive slope or a negative slope?
This question is from the 2022 and 2023 ACT. No, not the.
Okay.
Yes, 2022, 2023. Question 49.
No.
It's this graph.
This one. He's saying that point M will remain as it is, but point Q will move. So this is the line that we're talking about, MQ. Imagine if I moved Q along the x-axis to the right. So the line, right now, it has a very high or a very low negative slope, correct?
Yes.
Now, when this is a very low negative slope and then it becomes this way, is this a higher negative value or a lower negative value?
It should be lower.
Yes, and then it becomes this one, which is 0. It's not lower, actually, it's increasing.
Yes, but isn't it just going right?
So yes, but the M will remain. So it will become, for example, a line like this. And then it will go for another one like this. And then it will go.
Always be negative slope?
Yes, it will always remain negative because.
Slope will be decrease.
Yes, it will never become 0. Why? Because it will never go up until it reaches the M. The M will always stay up and the Q will always stay down. It's just a different slope, that's all, but it will never become 0. So this one is a very low slope. So this one is negative, let's say 20. This one is a negative 10. This one is a negative 5. It becomes closer to 0 as it's going to become more horizontal. Then the answer becomes closer to 0. So the slope is actually increasing. It's not decreasing.
Oh.
Do you get the idea?
Okay.
So the slope will increase, but will never be positive at any point, ever.
It will increase from negative to 0. So
no, it will not even reach the 0. It will not even reach the 0 ever. صح?
Yes.
So it will increase, but never to be positive. It will not decrease. It will not decrease. It will increase and eventually be positive. No, it will not eventually be positive. It will stay the same. That's not true. So D must be the correct one.
I thought it's going to be decrease, and I was in between A and B.
So that's my point. No, even though the slope, because the slope is already negative and it's coming to become more parallel to the x-axis, so it means it was a very low negative value and it became almost 0. So that's getting it higher, not lower. Okay. That's a very interesting question, by the way. Type number 9. In the xy plane, these are parallel. What is the length of AC in feet? So that's a similarity question mainly, and they're looking for AC, this whole shape together. So you need first to recognize what's the ratio between the small triangle and the big triangle. So I'll discuss, مثلا, I'll look at this one, small triangle, as the smaller one, while the big triangle is the whole ACB, or ABC, the whole big one. What's corresponding to this side in the bigger triangle? What's similar to it? Which side is considered similar to it? It's the AB entirely. So then the small over the corresponding big one, which is 21, 8 plus 7 plus 6, is equals to the small one, which is the 16, over the corresponding one in the big triangle, which is the AC. So if I need to find AC, I just cross multiply. So AC will be equals to 21 multiplied by 16 and then divide by 8, which means AC will be equals to times 8 times divided by 8. It's 221.42. Let me quickly recap what happened. If we have, let's say, a small triangle like this one and a bigger triangle like that one, and they are similar to each other. If you took this side over that one, so if this is x and this is y, x over y is equal to this side over the similar corresponding one, yani A over capital A, and equal to this side, which is B over the bigger capital one, so A, B over B. And whenever I have something missing, I can cross multiply and find it. Does this make sense? Not so much?
Yes.
Good. Mehmet, you're good?
Yes, sir. Find it easily just by checking 8 and 16. Since AD is 8 and A is 16, the ratio could be applied to both 7 and 6.
Here's the thing.
14 plus 12.
Okay, that's very, it's a very common misunderstanding. So the ratio works between two triangles, not sides of the same triangle. So you selected the 16 and the 8, but both are sides of the same triangle. It's like you're getting the ratio between the hypotenuse, for example, and any other side. But the ratios that we use are the ratios between a triangle and another complete triangle. So I have to always take one side over the same side, but in the bigger triangle. Does that make sense, Mehmet, or that did not answer the question?
Yes,
You get my point? So by luck or by chance, they used this number to become exactly the same ratio. It's the same ratio of 2, but that's not, that's just a coincidence. It's not something that would happen a lot. That's why, again, I want you to remember always we put the small one over the bigger similar one or bigger corresponding one in the bigger triangle. Are we good, everyone? Ladies
Yes.
and gentlemen, all good?
Yes.
This is the one where this is the same one we solved earlier. We solved it. خلاص. So then all four of them are done. I'd like to ask you a few things. Do you guys know the cosine law?
We took it last year, but I forget.
You forgot it. Okay. So there are two laws or two rules. These rules apply. They're using sine and cosine, and these rules, both of them apply in triangles that are not right triangles. So whenever it's not a right triangle, the rule could apply. What are those rules? So one of the rules is used whenever you have two sides and one opposite angle. So mainly if I have one side and opposite angle, I can use the sine law. Yani for example, if I know this measure and I know this side, and let's say مثلا this one is 10, this one is 30, this one is 15, and I want to know the measure of C. So mainly, again, I need a side and an angle opposite to each other. And I do have that. I have a side of 10 and the opposite angle, which is 30. Once you have this, the sine law states the following. Sine any angle over the opposite side is equal to sine any other angle over its opposite side, and it's equal to sine the third angle over the opposite side. What does that mean? It means that sine the 30 over its opposite side, which is 10, is supposed to be equals to sine the C, which is x, over the opposite side to C, which is 15. Now, if I'm trying to find x, I'll cross multiply, and I'll say that sine x is equals to 15 sine 30 over 10. Do this on a calculator, and then do shift sine to get the value of the angle itself. Does this make sense?
Yes.
So it's mainly just a cross multiplication procedure, and you must have at least a side and an opposite angle. While the cosine law, which is another law that still applies only in triangles that are not right triangles, the cosine law states that you need two sides and the middle angle. So if you have the measures of two sides and the angle between them, that's when we can use easily. Or whenever we're trying to link, generally just link between two sides and the middle angle, I use the cosine law. For example, if you have this one is 10 and this one is 15, and this one, for example, is 30, I want to know this side, so I do have two sides and a middle angle. I can use the cosine law. The cosine law states any side to the power of 2 is equal to any other side, let's call it this 10 to the power of 2, plus the other side to the power of 2, which is 15, and then minus 2 times both sides cosine the middle angle, which is the 30. So the rule actually is the following. A squared, any side squared, is equals to the two other sides, which are b squared plus c squared, minus 2 times the same two sides, and then cosine the middle angle, which is a. So if I need to find x, I'll just do square root of all of this. That would get me the value of x. That would get me the value of this side. Does this make sense?
Yes.
Yes.
I want to remind you that this is a very important rule because it's almost in every test it's there at least just once. It's there, so why not just remember it and use it? And other than that, there's nothing really to remind you of, and let's see what we guys can do. Let's go back to class 12. There you should be able to see 3 forms, P10, 11, and 12. P10 in this case, they have things about factors, things about the sine and the cosine that needs شوية thinking, and the measures of angles in radians. This one has a bit of an area. This one is a fraction where we're adding it. So these are supposed to be the easy ones, hopefully. There are 1, 2, 3, and 4 questions. So let's hope they won't take us more than 5 minutes. Five minutes for 4 questions. 5 minutes started now. So this was the first question in the first form, which was P10. It says here, given constants C, D, and M and N, such that x squared plus mx plus c has factors of x plus 2 and x plus 4. Now, generally, when I have the factors, I can easily do one of two things. I can either multiply those factors and get right away the original question. So by multiplying, you'll get x squared plus 6x plus 8. And then you can tell that m must be the 6 and c must be the 8. This is one way to sort it out. And do the same for the second question, where you're given the x plus 3 and the x plus 7. So you know for a fact that you're going to multiply these two. And once you do that, you'll get x squared plus 10x and then plus 21. You can also tell right away that this is the n and this is the d then. They're asking what's the value of m times n, which is 6 times 10. So it's definitely just 60. And the answer is D. Another way to look at it is, if you remember, I told you once that whenever x squared has a coefficient of 1, the number next to the x is the sum with the opposite sign, and the number alone is the product with the same sign. If you know that these are the factors, then you know that x must be equals to -2, and this x is equals to -4. If I need to find m, I just need to add them, get the sum, and switch the sign. So it will become -2 plus -4, which is -6, and switch the sign. So right away, m is positive 6. And if you check this one, here x will be equals to -3, and x here equals to -7. And if I need to just find the n, which is the sum with the opposite sign, I'll just add them and switch the sign. So that's another 10. Now mn must be equals to 6 times 10, which is also equals to 60. So 2 ways to do this. One I consider to be a bit faster, which is the one with the sum and the product. And there's another way that's a bit longer, but it guarantees a correct answer without any mistakes, is this one, where you multiply the brackets. Does everything that we explained so far make sense? Okay. No, doesn't? I feel like it doesn't. Okay. Now, what is the measure in radians? What is radians? So we usually measure the angles with degrees, and there's another unit of measurement called radians. Radians is also always includes pi in it. So you'll find it written as 3 pi over something, or 2 pi over 2, or 2 pi, or negative pi. It means this is the angle, but written in the radius, or using radians, and rather than using degrees. What you need to understand is that the pi is equals to 180. Pi is the similar, or is exactly the same as 180. So if I say sine 2 pi plus theta, it's like I'm saying 360 plus theta. Now, if I add a 360 to an angle, doesn't it return back to it's the same exact location? So if I add to something 360, I'm mainly kind of, if this is a circle, I'm starting at one point and then going back to the same point again, because 360 is a full circle and repeating again from the beginning. So the sine of just theta will get me the exact same answer as sine 360 plus theta, or 720 plus theta, which is 360 and 360. or even 360, 360, 360, which is 120, I guess, or something like that. So if you keep adding 360s to an angle, its sine and cosine and tan will not change. It will remain to be the same sine and cosine and tan. Does this make sense?
Yes.
Are you sure?
Yes.
Okay.
Maybe.
Yes, of course. So again, we just said that pi is considered equals to 180. If I said 2 pi plus theta, it means I'm adding 360 plus theta. When I add 360 to an angle, the sine of it, or the cosine of it, or the tan of it will remain the same. So if you try on a calculator, for example, sine 30, that's half. And if you try sine 390, will also be half. So when you add full 360 to the angle, its sine, cosine, and tan will not change. It will remain as it is. If you add even 720, which is 360, and another 360, will still remain the same. The only problem is whenever you add an angle that's less than 360 or bigger than 360, then the sign will change definitely. I'm calculating the sine of 30 and the sine of 390. Yeah. Does this make sense, Aline? Does this solve actually and answer your question, or did I not do that? Right. Now moving to the next one.
I understand.
A small circle and a large circle are tangent at T, which means they touch each other only at this point, as shown in the figure above. The large circle lies on the small circle. The diameter of the large circle is 12. What's the ratio of the area of the small circle to the area of the large circle? So mainly if I say that so I'll need to get the area, or if I need to get the ratio between any two things, it means I'm supposed to divide them. So I need to get the area of the small circle and get the area of the large circle and divide them by each other. So again, I just need to get the area of small divided the area of large. So how do I get the area of the small circle? Apparently this diameter is 6, which means from here up till here, that's 12. So this here is 6, which means that the radius of this circle is 3. So the area of the circle is pi 3 squared, which is 9 pi. This is the area of the small circle. Divide this by the area of the large circle. Apparently the large circle has a diameter of 12, which means that the radius is 6. So pi 6 power 2, which is 36 pi. This is the area of the large circle. I'll divide now both by each other. So it's 9 over 36. Divide both by 9 and you'll get 1 over 4. So it's 1 to 4. If this wanted to be written in a different form, I can write it this way. 1, 2, 4. This is okay and this is okay. They're the same. Does this make sense, everyone? Are we good?
Yes.
Awesome. Moving on to 50. We have here two fractions with different denominators, just similar to the question we solved earlier. So I have to make them have the same denominators first, which means I'll have to add here 2a, and I'll have to add here b. Once I add something on one side, I have to add it on the numerator and the denominator. So when you look up here, 2a times 2a, that's 4a squared. And then b times b, is b times b is b squared. For the denominator, it becomes 2a multiplied by b only once. So then J must be the correct answer. If I have A over BC added to D over BX, then here the B's are common, but the C and the X are different, which means I'll add only to this left fraction only an X up and down, and for this right fraction only a C up and down. So that will get me XA plus DC over XBC. I'm just giving you another example of fractions and what could be the types of questions that could pop up there. Does this make sense as well?
Yeah.
52. We said this symbol here, GOF, means G of f of x. That means that I need to put f of x inside the G. So instead of this x, I'll open up a bracket, كبير, big one. Inside the bracket, I'll put the f of x. Sorry. I did not even notice that this is not f of x. You are actually given f of g of x. And this was it, cubic root of x plus 1 minus 2. So that means that the g of